Boom. All right, folks, we continue on the material for this week. I changed my shirt. I just wanted to go a little bit more Hawaiian, okay? I love this Hawaiian shirt. You do too. I know you do. You're all jelly out there going, I wish I had that shirt. Okay, diving in. Now, if you look at the list of things that we're doing, we've gone through limited reactants. Yes, we have. We've done that. We did that in that last video. And we're going to move from stoichiometry. Yay! That's what some of you are out there saying, right? Thank goodness. And move into what are called solutions. Solutions, muy importante grande. You are a solution, a walking, talking, hopefully breathing solution. A solution, if you look back at the video, the very first video set, I put one in there because I thought she did a good job on different kinds of matters. She had set it up exactly like I would have set it up. So I didn't make that video, but had I done it, I would have done like her. And she went over solutions. And solutions, I will go over it right now, important because we're doing a whole unit here on solutions, are you're going to have, okay, solutions. You've got to have your solute and your solvent. Solute and solvent. You might have heard the universal solvent's water. Well, that's because it dissolves so many things. So many things will dissolve in water. We're going to find out not everything dissolves in water, but most things do. A lot of things do. So the solvent is that thing that the solute gets dissolved in. Okay, so in other words, when it comes to an example, the most common solution on the planet is the ocean water, salt water. So salt water. So in that example, the solute would be the salt. It's the thing that gets dissolved. It's the thing that gets distributed throughout the solvent. And the solvent, in my example, would be the water. It's the thing that does the dissolving of the solute. Okay, so salt water, a very common solution. There are other kinds of solutions, and the most common solutions are water solutions. Those are the most common, but they're not the only ones. And so people tend to think that, or students tend to think that solutions are all liquid with a solid dissolved in it. They're solid liquid combinations. No, they're not. Most of them are, yeah, because there's so many of them, but not all of them. So when it comes to solutions, you can have other kinds of solutions other than solid, okay, salt dissolved in liquid water. There can be, you could have a gas solutions. You can have gas solutions. Maybe some of you are drinking a gas solution right now, having a nice little diet soda or something like that. If you do that, then you're going to have carbon dioxide gas dissolved in water. All right, so that would be a gas liquid solution as opposed to the solid liquid solution of sodium chloride dissolved in water. And there are many salts which dissolve. Sodium chloride is very common, but there are all kinds of salts. I've talked earlier about what a salt is. It's when you have a metal and a non-metal. If you have a metal and non-metal together, like copper and nitrate, that is a salt. So any of those metal, non-metal combinations, most of them, not all of them, but most of them will dissolve in water. Okay, well, what else? What about a liquid in a liquid? Is that possible? You can have a liquid? Absolutely, absolutely. You could have alcohol, which is a liquid, dissolved in water, which is a liquid. That would be a liquid solution. Alcohol, like if you were to go and get a bottle of vodka, 21 means 21, okay? 2-1. And you bought one and you looked at it, it would have a proof number on it, usually 80 proof for most of those what are called hard liquors. So 80 proof means 40% alcohol. You take the proof and you divide it in half, you get the alcohol content percentage. 40% alcohol, so that would be 40% alcohol, 60% water. That is a solution. The reason it's a solution also, we gotta go back over this, a solution is anything that just has one phase. And one phase meaning you just see one thing. You don't see the thing that's dissolved in the solvent. You don't see that. You don't see the solute. You don't see the salt in the water. You don't see that. You don't see the alcohol in the water. You look at a bottle of liquor, you're going to see it's all just looks like one thing. You don't see two things in there. Carbon dioxide, you will not see the carbon dioxide when it's in the soda. You will if you do that, you a little bubble out will come out. That has to do with pressure, something called Henry's Law. We will actually talk about that in the not too distant future. But you will not see the CO2 in the water unless you release the pressure and allow that CO2 to escape. So it's one phase. You see one thing. Kool-Aid. Okay, Kool-Aid. Sugar water. Not salt water, but sugar water. That's what Kool-Aid is, sugar in water. Sucrose dissolved in water. You don't see the sugar. You don't see that at all. You see the, hey, Kool-Aid. One day when I yell out, hey, Kool-Aid, that big Kool-Aid container is going to come crashing through the wall. It's going to be sweet. Not today, though. Bummer. If you have cherry Kool-Aid, you just see cherry color. You don't see anything in there except the cherry color. You see that one phase. Okay, another example would be alloys. Alloys, okay? Have you ever heard of an alloy? You know the alloys, the United States, Great Britain, and the Soviet Union back in World War II, Axis and alloys. I thought it was funny. Okay. No, not those alloys. An alloy would be something like brass. Brass is an alloy. You have two solid metals that are just kind of melded together. It looks like, if you see anything brass, it looks like brass. If you've seen brass, you know what brass looks like. Solder, if you're a solder or a person, that is an alloy. I don't remember the metals in that one, but there's lead in there, I believe. I don't remember what the other one is. But those are steel. Steel is an alloy of solid. It's mostly iron, but there are other things thrown in there. If it's hardened steel, it could have some titanium in there and some other combinations of stuff that you don't see them. It just looks like steel. Okay? But there are a combination of these things kind of melded together. All right, now, what about, a gas. You're breathing one in right now, hopefully. Okay, breathe, people, breathe air. Air is a gas dissolved in a gas. Wait a minute, gas dissolved in a gas? And so, like, what's the solvent? And what are the solute or solutes? Okay, exactly, so let's talk about that a little bit. When it comes down to who the solute and solvent is, you're talking about the majority of it when it comes to something like gas dissolved in gas. So the majority of our air that we breathe in is nitrogen. Okay, it's mostly nitrogen. And then the next one is oxygen, about 21% oxygen. And a few percent, 1-ish percent of argon. There'd be some carbon dioxide, water vapor. If it's a humid day or not, there'd be more. So it's mostly nitrogen. It's 78% nitrogen, if I remember correctly. So the nitrogen, since it's the most common of all of those gases, would be considered to be the solute, and the others are the solvents. Okay, that's the same thing with our liquid. When we go to alcohol and water, I was talking 80 proof earlier. There's a kind of alcohol, it's called, it's a rum, Bacardi makes Bacardi 151 proof. That's 75% alcohol. So in that case, you switch. The water would not be the solvent. In that case, the alcohol would, because there's so much more alcohol. All right, so the dominant one is the one that you have the most of when you have these like phases, gas, liquid, solid. The one you have the most of is the solvent. All right, I think we've talked a lot about solutions, different kinds of solutions. So there's not just solid, dissolved, and liquid. No, that's common, but not most. But there are other kinds. And the solutions that we're doing in this unit are water solutions. Okay, I mentioned the others to mention that not all solutions are water, but we're going to be doing water solutions in this unit. Yes, we are. All right, so let's get down to brass tacks. Oh, one last thing I just wanted to point out about our water solutions before we start doing some calculating. The water solutions are that if you dissolve a salt in water versus, let's go with glucose. Or sucrose. Sucrose. It's 11, that's 20, no. Okay, that's dehydration synthesis. So 2 of those, take out 1 of those, dehydration synthesis, C12, H22, O11. Okay, You remember your dehydration synthesis. It's tough to say if you say that 10 times fast. From your old biochemistry class, right? You remember, yeah, you take 2 glucose, put them together, make yourself a sucrose molecule. All right, let's see. What I wanted to point out, though, is you dissolve this in water, this separates into sodium ions and chlorine ions floating around in the water. This does not separate. No, you do not break that down. What happens is you have a lump of sugar, it just forms smaller and smaller until you get to the molecular level, a molecule of your sucrose. You get molecules of sucrose floating around. You don't break sucrose up. But when you take a salt and dissolve it in water, it does break up. Okay, well, who cares? So what? Who cares? This, because you have positive and negative ions, is called an electrolyte. That would be electrolytic. You've heard of that. Replace your electrolytes. Hydrate properly. Drink Gatorade. Well, that's because you have these ions from the salt, and Gatorade is saline. It has some salt in it to replace your ion loss when you sweat. So that would be electrolytic. And electrolytes can also conduct electricity. So salt water is a conductor, not a great conductor of electricity when it comes to conduction, but it can conduct electricity because it has these salts dissolved in it. Okay, so salts create electrolytes. Non-salt that dissolve, like sugars, do not, or alcohols which dissolve in water, those do not make an electrolytic solution. All right, I think we've wrapped up the basics about solutions, and we'll dive into calculating in the next video.